I'm Tyler Perry, Assistant Programmer and Lead Builder.
I'm Haley Egbert and I'm Lead Programmer.
I'm Madison Gilger and I'm Team Manager.
I'm Madeline Smotzer and I'm Director of Design Concept.
And we're Team L.
The AEV labs existed in order to fulfill Jurassic Park's need of a monorail system that could transport passengers into the park. The monorail was required to be an energy-efficient, low-cost, unmanned system that could move forward and backward using air propulsion. These labs introduced the main concepts of the AEV, which were to understand and build a low-cost and consistent transportation system with a focus on energy management. Each team member was required to make orthographic sketches of their AEV design. Tyler's design consisted of 2 rear-facing propellers with an aerodynamic covering in the front. This design also had angled wings coming off the back for a more balanced and aerodynamic feel. Madeline's design also had 2 rear-facing propellers. This design did not include a cover, but instead had 2 sets of back wings in an X-shaped fashion to add more back weight for balance. Haley's design was similar to the sample AEV with 2 rear-facing propellers and a front covering, but had flat horizontal wings instead of angled ones that the propellers attached to. Maddie's design was also very similar to the sample, except it was bigger in size and also had the flat horizontal wings, adding to the balance and stabilizing the AEV.
The AEV project had 4 main areas of error. The first area of error has to do with the battery. The batteries were charged at different levels, and when you ran the code, a little bit of battery was taken each time, so our code was not consistent. The next place for error was in the differences between the tracks. We started out the experiment using only the track in the lab room, and then once we progressed in the experiment, we started to use the track in the lecture and the lab room. We found the tracks to be a little bit differently and had to change the coding each time respectively. Our next place for error had to do with our Arduino port. At one point when we were trying to upload the data, the port fell off and we became set back because we couldn't upload any of that data. We had to get a replacement and rerun those trials. The final place for error we had to do with the MATLAB program. When we were trying to upload the data, the MATLAB program did not always work in the same fashion, and we would have to either restart the MATLAB program or record new data at points.
This design had too much blockage, bad balance around the corner, and was less efficient than the next design. This T-shaped design was lightweight, properly balanced, and fit nicely into the AEV box. For our final design, we want an AEV that was simple, easy to maintain, easy to transport, and cost and energy efficient. And we decided to go with a T-shape with 2 dual rear-facing push propellers.
Throughout the AEV Lab series, Team L learned many things. We learned how to work as a team and how to divide up the responsibilities equally. We learned how to problem solve on the spot when many things went wrong, such as the Arduino port falling off. We also learned time management and how to complete a long-term project.